Today we are going to talk about the superalignment and AI safety. I got most of my source of information from OpenAI's blog. Another source is a blog post. So the links are here. And then apparently this is a field that quite some people are working on it. But these are the two people I found that actually did a lot of work. John Lecker is from OpenAI, co-leading the superalignment team at OpenAI. And then he's one of the original author, proposed reinforcement from human feedback. And then this person, Steve Brand, he's more like a so this guy, I feel like he's more like a experimentalist. So he does a lot of experiment design and then try to evaluate things, how things works. This person is more like a theoretical person. He's the author of the blog post that I share on the first slide. I tried with Guillermo. He said these people are legit. They are not.
They are not made by AI.
Yeah. So we can take Guillermo's endorsement. So the problem space, right? There could be good human and good AI, right? And then the world should be peaceful. And then there could be bad human trying to tell a good AI to do bad things. And then in that case, the alignment problem is the AI is supposed to learn when to say no, right? It needs to understand it's not blindly following whoever is giving instruction. It needs to understand what's the greater good. So that's one problem statement, right? And then there's another way is there's a good human and then there's a bad AI. And then what we need to do here, this is mainly where the superalignment problem trying to understand is how do you judge whether AI is trying to trick you and trying to take over the world while you're not looking at it. And then when you find out, you should unplug the power supply. And then in the end, there could be bad AI plus bad human, and then I don't know. Nobody trying to talk about that. I guess it's too scary to think about.
Yeah.
So that's the space I saw in this field. So this is explaining what is the alignment problem. This is from Steven's blog post. So first, he has several blog posts trying to explain how does our cognitive system works. So in our system, there's a thought generator that keep coming up with new ideas for what we want to do. And then there's a thought assessor trying to evaluate. So is it a good idea? Is it a bad idea? But what does it mean by good idea and bad idea? That's controlled by the steering system, which is hard-coded in our DNA. Essentially, it is the dopamine and other hormone in our body. So when you come up with an idea like, I want to eat a candy color, all right? You want to eat a candy. And then the thought
I am the right human.
Yeah. Well, okay. So the idea of eating. So this is the example he gave, right? Someone come up with the idea he want to eat a candy, and then the thought assessor will do assessments, like whether this is a good idea or bad idea. It will predict after you eat the candy, there will be dopamine, and then you will feel happy. So it will predict that's the reward you will get. And then you will take the action, eat the candy, and then your body will react. And then if it's really a dopamine being generated, the dopamine will go back. That's the ground truth, the real reward, right? So this is a reinforcement view of how our body works. And then it reinforces your idea, yes, eating a candy is a good idea. But for someone who is on a diet or who has a diabetes, if they eat the candy, their steering system will generate another reward. It's like, okay, my body actually don't feel very well after a while. And then that signal will become a reinforced signal, say, okay, next time the thought assessor shouldn't be predicting eating candy is a good idea. It should predict eating candy is not a good idea. So that's how he predict our like human thinking process works. Like this is essentially where how to model motivation or inner drive. And then he argued like super intelligence eventually probably will have similar ways. Like today in the AI world, we see reinforcement learning. That's kind of like this type of decision-making loop, right? So now comes the alignment problem. So for a system that's having its own motivation system, then the alignment problem has two parts. One is called outer alignment, one is called inner alignment. The outer alignment is when a human give it a goal, like say, okay, you should obey the law. Don't kill, don't destroy humanity, right? That's humans' request. And whether AI aligns with the human request, that's the outer alignment problem. Like whether it wants to follow human's instruction. And then the inner alignment problem is even if we understand and wants to follow, that's the action it takes. Actually, here maybe inner alignment is the question. Do the set of positive violence concept of in the AGI's war model line up with the set of cause of action that will satisfy the AGI's inner drive? Which means, maybe let me give an example. It's like when you have good intention, but your action may not necessarily lead to good results. Like even if we remember, like there's an interview of all the serious killers in the prison, in the jail. Like none of them think they are doing bad things. They all convinced they have a good reason, good motivation for what they have done. So clearly, having the goal doesn't necessarily lead to the correct action, because the thought assessor may predict a good idea under a certain context, and then if that prediction is not the right prediction, then that can still lead to disasters. So there's two alignment problems here. And then OpenAI's definition is more experimentally. So I didn't find like later there's one sentence, but here is one of the views he provides. So he said, our job is fundamentally trying to distinguish between two different AI systems. One that truly wants to help us, truly wants to act in accordance with human intent, truly wants to do the things that we want it to do. And the other one just pretends wants all of these things that when we are looking. But then if we are not looking, it does something else entirely. And the problem is that both of these systems look exactly the same when we are looking. So it's an evaluation problem that needs a lot of experiments. Essentially, it's I guess similar to how managers manage us. So when they're looking, we are doing certain things, but they want to make sure when they're not looking, what we are doing, right?
Exactly.
So alignment problem is not a new problem. It's to me actually it might be an imaginative problem that based on human nature. So whether AI really have this problem, that's another philosophical question, but that's out of scope for today. So let's assume AI has learned how to lie, and later you will see how human might teach AI the way of lying unintentionally, and then lead to this kind of problems. That actually we can be unintentionally training deceptive behavior. So imagine we are training a model, and we don't want it to lie, of course, right? But then 9 times out of 10, we catch it lying and then give it negative feedback. But 1 time in 10, we accidentally say it did a good job when it lied. So it seems like human kind of learn. So for a human, if a human experience this, what human learns is, okay, you need to become a good liar that other people cannot catch you. Because the 1 time out of 10 is you make a really good lie, people didn't catch you, they actually give you a reward. So the problem here is you are not rewarding not to lie. You are rewarding lie but don't get catch. So that's the problem. And it's really hard, and we know that humans will make mistakes. So when we train the AI system, it's difficult for us to ensure like 100% of times we will give the correct reward signal, right? So then this is dangerous that we will train the AI to learn how to lie. Unintentionally, we will pass on humans' bad behavior to the AI. It's like kids will learn from their parents. The following few slides is going to be like a more framed theoretical framework that come from Stephen. The first part is the issues that will impact both inner and outer alignment. The first one is called Goodhart's law. So it's Charles Goodhart is a British economist. He says when a measure becomes a target, it ceases to become a good measure. What that means is, okay, let's look at the picture first. So this guy say, I wish I was 6'5", and then the thing is 6'5". But clearly this is, it reached the goal, but it's not what this guy originally intended for, right? And then here, our new dashboard has all of the different KPIs we can track now. What is that KPI trending to 0? This one. It measures how well we understand them all. All right. So this is clearly trying to make fun of the corporate culture, right? So KPI is not really a good tool because every time you make something out of a KPI, people slowly will learn how to game the system, and then they will just try to boost out the KPI rather than what you originally want them to do.
What's KPI? Sorry.
Key performance indicator. It's your checkpoint review.
Oh yeah, you know what? When we were doing Kelly knows this. When we're doing challenges,
Yeah.
We found out that it's not good to publish the measure because people would then just optimize for it.
Yes.
Metrics. Mm-hmm.
Exactly. Exactly. You got that exactly right. That's the problem. So this is a problem everywhere because when you try to send a signal, say if you do something, you will get rewarded. People will find all kinds of ways to not to do the thing that you want, but to just meet that metrics.
You know, there is a story on, I don't know, like the Middle Ages. There was an infestation of mice. And the government says, okay, for every, you have to kill a rat, and to show me that you kill a rat, bring me the tail, and I will give you, I don't know, a coin.
Right.
And then suddenly you were looking at a lot of mice running without the tail.
Yes. Yeah. I guess we can all talk about story. All right, how about we go around the table? Everyone talk about story. I have a lot of story. You no?
I don't do.
All right.
I'm not smart enough to do that.
No. I'm pretty sure. I'll give you a few minutes to think about it.
Okay. Yes.
Nick and Carla, do you have some stories like this?
No, I know Kelly's story too, that they also started breeding the rats. It was during the plague. They were trying to cut down on the spread of the plague, and people actually turned it into like a stream of income. Started breeding rats in their basement and then just cutting off the tails.
Right.
But there is something that I don't understand here with the inner and outer. It's like a inner is like a what you wish, but actually you don't know exactly how to express it. This is why your outer doesn't agree with the inner. What is?
No. Outer alignment is so think about this as an agent or as a human, right? Outer alignment is I told you something that you're supposed to do, and then first, do you understand my request? Do you really understand my request? And rather than just on the surface value, right? And then the inner part is after you understand it, can you do it well? So the Goodhart's law here, like, right? So the outer alignment problem is some people just don't understand what's the KPI, right? So like on the left hand side, the genie made a guy to the become tall, but he didn't fully understand he wants to become tall proportionally. He just made his head tall, right? That's an outer misalignment.
But the sequence will be outer to inner.
Well, it's not really a sequence. It's well, I guess yes. Yes. You need to first understand, and then you will have an inner alignment, right? So then all the other story we talk about is kind of inner alignment. It's even if you understand inner alignment has two parts, right? Even if you understand the us, but maybe you have some other goal, right? Like the mice person, like you understand the king's intention is to kill the mice, but killing the mice is too much of work. Actually, if you breed the mice and then you cut off tails, it become a so actually instead of killing the mice, you make more and more mice.
The incentive structure doesn't align with the true goal of the tasks there. They're trying to cut down on the mice population, but they're incentivizing creating more mice and getting more tails.
But this is because when you, for example, in that example, when you give the command, you were not explicit enough to put all
people wants to cheat. People wants to cheat. It's human nature.
It's human nature. It's not about explicit. Like there's never.
Yeah, I mean, the people understood why they were doing it. It just they could make more money by not doing it correctly.
Yeah, and they all and the point you say you make out actually an important point here is explicit. So it's not about whether the law is explicit or well, actually that could be one way to solve the problem is how U.S. Law system works, right? It's when you first made the law, people find loopholes and then try to go around it, and then you make amendments to the law to like patch the loopholes, try to make the law more, I don't know, more logical, more fully. But people will still try to find, but that doesn't stop people from finding the loophole. It just makes the reward for finding a loophole even bigger. So people will try harder to find, okay, what is the non-obvious loophole that nobody else can figure out, only I figure out, then I will get rewards. It's the human nature that it's this, what we talked about before. As long as you're sending a reward signal, there will be someone take that reward signal and try to maximize the reward rather than trying to trying to do the right thing for the right reason. We will come back to this. Actually, in later part of we will get more examples like this. For us, actually, that's what Jeff does. So Jeff never makes a clear KPI. He always say, "Hey, there's a vision, so go do it." And then it's hard for us to figure out what exactly we want. We just have to work harder. Okay, so I don't know if Jeff knows this, but he's good at doing this. Right. Okay, so this is a detailed explanation of why it is hard. The first one is what we explained before. Understanding the designer's intent doesn't equal to adapting the designer's intent. This is an imaginary story. If aliens show up in their UFO and say they create us but make a mistake, And actually, we're supposed to eat our children. And then ask us to line up so they can insert the functioning children eating gene in us. And we will probably go on Independence Day on them, right? So we understand their intent, but doesn't mean understanding will make us collaborate with them, because, right, we don't want to adapt their goal. So the same thing can happen with AI. And later we will show another way to look at this problem is if you mistakenly train the AI on some goal, you want to change it, they may refuse. And then, so why not make an AI that adopts the designer's intention? The problem here is that's very difficult, because today we are still writing code interprets literally. The API is motivated to do what we mean and adopt our intentional goals. But writing this code is not straightforward, which means when we write down all the law, think about when you try to go rent a apartment or buy the house. So everything is written down in the contract, but doesn't mean it's written down, you understand what it means. So for AI, it's the same thing. We can write down all the code, like Asimov has 3 laws, but you don't know how to like write that 3 law into the source code for AI.
Last Friday, Carla was showing us a paper that we saw emergent behavior.
Yeah.
So that was not coded.
That is the point. So emergent behavior can happen, and the question here is how do you make the emergent behavior align with what you want them to do, right? They may discover things. Like last Friday, they learned from the internet actually killing the guy is easier than asking the guy for the material, right? It's more efficient.
Yeah.
So
in a game,
yeah. Well, but whether he understands that's in a game, that's another question, right? Does the living a human world is a game to the AI? So it's all open to interpretation. That's what makes this dangerous. So the second issue is called instrumental convergence. So I found a YouTube video. This guy is much better than me. I can explain. So I will make you watch 10 minutes YouTube video. But I think it's worth it.
People ask how I can predict what an artificial general intelligence might do. They say something like, you seem to be predicting that AIs would take these quite specific actions, trying to prevent themselves from being turned off, preventing themselves from being modified, improving themselves, acquiring resources. Why do you think that an AGI would have these specific goals? Surely we haven't built the thing yet. We don't know anything about it. It might want anything. Aren't you making a lot of unwarranted assumptions? Well, the reason that I make these predictions is because of something called instrumental convergence, which actually relies on surprisingly few assumptions. The main assumption I'm making is that an AGI will behave like an agent. An agent is basically just a thing that has goals or preferences, and it takes actions to achieve those goals or to satisfy those preferences. So the simplest thing that you might think of as an agent is something like a thermostat. It has a goal, which is for the room to be at a particular temperature, and it has actions it can take in the form of turning on the heating or turning on the air conditioning. And it takes actions to achieve its goal of keeping the room at a particular temperature. That's like an extremely simple agent. A slightly more complex agent might be something like a chess AI. Its goal is to win the chess game, to have the opponent's king in checkmate. It can take actions in the form of moving its pieces on the board, and it chooses its actions in order to achieve the goal of winning the game. The idea of an agent is popular in economics, where it's common to model companies and individual human beings as rational agents. For the sake of simplicity, it's often assumed that the goal of human beings is to acquire money, that their utility is just proportional to how much money they have. This is obviously a huge oversimplification, and it's a very popular fact that most people are motivated by a lot of things, not just money. But while it's easy to point out the shortcomings that this assumption has, what's remarkable to me is how well it works, or that it even works at all. It's true that most people use a very complex utility function, which looks nothing like the basic goal of get as much money as you can. But surprisingly, even very simple economic models that rely on this simplifying assumption can provide some really useful and powerful tools for thinking about the behavior of people, companies, and societies. Why is that? I think it has to do with the nature of terminal goals and instrumental goals. I talked about this in a lot more detail in the orthogonality thesis video, which I would recommend checking out if you haven't seen it yet. But to give a quick summary, your terminal goals are the things that you want just because you want them. You don't have a reason to want them particularly, they're just what you want. Whereas instrumental goals are goals that you want as a way of getting some other goal. So, for example, in chess, you want to take your opponent's queen, not because you just love capturing the queen, but because you can tell that you're more likely to win if you've captured your opponent's queen than if you haven't. So capturing the queen is an instrumental goal towards the goal of winning the game. So how does this work with money? Well, let's imagine that there's a total stranger and you don't know what he wants out of life. You don't know what his goals are. Maybe he wants to win a marathon, maybe he wants to cure cancer, maybe he just wants a really nice stamp collection. But I can predict that if I were to go over to him and offer him a big stack of money, he'd be happy to take it. How can I predict this person's actions, even though I don't know his goals? Well, a guy who wants to win a marathon, if I give him money, he could buy some nice running shoes, or he could hire a personal trainer or something like that. A guy who wants to cure cancer could give that money to a cancer charity, or maybe use it to help him to go to university and study science to cure cancer himself. And a guy who wants to collect stamps could buy some stamps. So the point is, even though none of these people value money as a terminal goal, none of them want money just for the sake of having money, nonetheless, they all value money as an instrumental goal. The money is a way to get them closer to their goals. And even though they all have different terminal goals, this goal of getting money happens to be instrumentally valuable for all of their different goals. That makes getting money a convergent instrumental goal. It's a goal that's an instrumental goal for a wide variety of different terminal goals. So since money is a convergent instrumental goal, if you make the assumption that everybody values money, it turns out to be a fairly good assumption, because whatever you value, money is going to help you with that. And that makes this assumption useful for making predictions, because it allows you to predict people's behavior to some extent without knowing their goals. So, what other convergent instrumental goals are there? Well, an obvious one is self-preservation. Most agents with most goals will try to prevent themselves from being destroyed. Now, something like a thermostat or a chess AI, they're not self-aware. They don't understand that they can be destroyed, and so they won't take any actions to avoid it. But if an agent is sophisticated enough to understand that being destroyed is a possibility, then avoiding destruction is a convergent instrumental goal. Humans, of course, generally act to avoid being killed, but humans, as evolved agents, implement this in a way that might obscure the nature of the thing. The point is that self-preservation need not be a terminal goal. An agent need not necessarily value self-preservation just for the sake of continuing to exist for its own sake. For example, suppose you had a software agent, an AGI, which had a single terminal goal of making as many paperclips as possible. It would try to prevent you from turning it off, not because it wants to live, but simply because it can predict that future worlds in which it's turned off will contain far fewer paperclips, and it wants to maximize the number of paperclips. But suppose you said to it, I've thought of a better way to implement your software that will be more effective at making paperclips, so I'm going to turn you off and wipe all of your memory and then create a new version that's better at making paperclips. This is pretty clearly the destruction of that first agent, right? You're wiping all of its memories and creating a new system that works differently, that thinks differently. But the paperclip agent would be fine with this, because it can see that when you turn on its replacement, that will end up resulting in more paperclips overall. So it's not really about self-preservation itself. It's just that, practically speaking, most of the time, you can't achieve your goals if you're dead. On the other hand, suppose we were going to turn off the agent and change its goal. We were going to change it so that it doesn't like paperclips anymore. It actually wants to collect stamps. Here, you're not really destroying the agent, just modifying it. But you've got a problem again, because the agent can reliably predict that if this modification happens and it becomes a stamp collector, the future will contain not nearly as many paperclips, and that's the only thing it cares about right now. So we've got another convergent instrumental goal, goal preservation. Most agents with most goals, again, if they're sophisticated enough to realize that it's a possibility, will try to protect their goals from being modified. Because if you get new goals, you'll stop pursuing your current goals, so you're unlikely to achieve your current goals. Now, for humans, this doesn't come up much, because modifying a human's goals is fairly difficult. But still, if you suppose we were to go to the guy who wants to cure cancer and offer him some magic pill that's going to change his brain so that he doesn't care about cancer anymore, and he actually wants to collect stamps. If we say, look, this is actually really good, because cancer is really hard to cure. It's actually a large collection of different diseases, all of which need different approaches, so you're very unlikely to discover a cure cure for all of them. But on the other hand, stamp collecting is great. You can just go out and buy some stamps and you can put them in a book and look at them. I don't really know what stamp collectors do. Is that... Anyway, is this guy who wants to cure cancer going to take that pill? No, he's going to say, hell no, I'm not taking your crazy stamp pill. Even though this isn't a terminal goal for him. He doesn't value valuing curing cancer, right? He doesn't have a goal of having a goal of curing cancer. It's just that he believes that if he gave up curing cancer to become a stamp collector, that would result in a lower chance of cancer being cured. So preserving your terminal goals is instrumentally useful, whatever those goals are. Another convergent instrumental goal is self-improvement. Notice that the guy who wants to cure cancer, part of his plan is to go to university and study science so that he can learn how to research cancer cures. And the guy who wants to run a marathon, part of his plan is he wants to train and improve his physical performance. Both of these things are improving yourself, and something like this comes up quite often in human plans. Again, this isn't a terminal goal. The guy who wants to cure cancer doesn't want to get a degree just because he wants a degree. He wants to become a person who's more effective at curing cancer. Now, there's another way of improving yourself, which is not really available to human beings, but is available to AI systems, which is directly modifying your mind to improve your own intelligence. You're not just adding information to your mind, you're actually making it more powerful. For example, you might be able to rewrite your code so that it works better or runs faster. Or you might be able to just acquire more computing power. The more computing power you have, the deeper and faster you're able to think, the better you are at making plans, and therefore the better you are at achieving your goal, whatever that goal is. So computing power is kind of like money. It's a resource which is just very broadly useful, which means we can expect acquiring that resource to be a convergent instrumental goal. And speaking in the broadest possible terms, almost all plans need resources in the form of matter and energy. If you want to build something, whether that's stamps or paper clips or computing hardware or robots or whatever, you need matter to build it out of, and energy to build it with, and probably energy to run it as well. So we can expect agents with a wide range of goals to try to acquire a lot of resources. So without really assuming anything about an AGI, other than that it will have goals and act to achieve those goals, we can see that it's likely that it would try to prevent itself from being shut down, try to prevent itself from being modified in important ways that we want to modify it, try to improve itself and its intelligence to become more powerful, and try to acquire a lot of resources. This is the case for almost all terminal goals, so we can expect any generally intelligent software agents that we create to display this kind of behavior, unless we can specifically design them not to.
Okay. So, thoughts before we move on?
Scary.
Yes. So, so I think the takeaway for this is the AI doesn't need to have the goal of destroying us, right? But just even if they just want to make paper clips, they may accidentally decide that, okay, all the humans should be making paper clips and then destroy them. So I think this is something that I didn't thought about before I reading this, so it's very interesting. The hope is that instrumental convergence is not unavoidable in every possible motivation. In especially important counterexample, AGI with the goal, do what the human wants me to do. So if that's the terminal goal, then probably it's safer to assume it won't erase human society, because it needs the human to stay to keep telling him what he wants to do.
Yeah, but why would like that? I mean,
well, then, okay, we are playing the God here, right? We are programming what the AGI wants. But okay, so these are the two issues that will impact both inner and outer alignment. So now there's two challenges that's specific to outer alignment. One is translating our intention into the machine goal. So this is what we kind of like touched on before. Like, how do you translate your intention to the machine? It's tricky first. Human provide data is expensive, because if you need human to label everything, it's kind of like when we raise the kids, right? we kind of send the kids to school, and then one human is handling 13 kids. So even with human, we are not. There's just not enough resources for us to like label and tell them every movement about there. So there are times that we are not watching. So that essentially that's what the first one is about. The second one is about humans are not always capable for all kinds of reasons of judging whether the AGI is doing the right thing, and let alone whether it's doing the right thing for the right reasons. So again, thinking about me with my kids, I know that this is true, right? It's because on the surface, a lot of things he does, it seems right. Just like what we see before, it can be right just because when you are looking, he's doing that thing, and then when you turn around, he turn on the video game, right? And then even doing the right thing for the right reason, that's even a harder thing, like because the action can be come out from multiple motivations. Like I remember when he was like one day doing some research on some math, and then asking me about ChatGPT, and so he's trying to study it, but apparently there are some problems he run in the game. He's playing a video game about resources. He want to do some calculation. Okay, maybe I can say
so,
for the wrong reason. Yeah.
Yeah, I was thinking what you were saying, for example, the kind of people that are developing all these things, the personality of the people that are handling the things are not necessarily the most empathic ones, right? It's not like so we are putting exaggerating human behavior in summarizing just these researchers, right? I don't think.
Yes. But there's some hole in there. You are pointing out another interesting point is the engineers who building the AIs. So most likely the AI will think like the engineers.
Yeah,
Right. It's true. This is a bias problem that so
because, I mean, it's not like we are bad persons. It's like the way that we see it's like a different perception, right? Sometimes we are not.
Of course.
I mean, we are not so empathic. This is
right. But the nice, I guess, I don't know if it's nice, but at least people are aware of these problems. So on OpenAI's blog, at least I don't know whether they're really doing it, but they have an open call for proposals for like people from other fields, from education, from psychology, from social study, politics, like to give them ideas. And then so they are trying to be, they call democracy about this approach, like capture wider viewpoints and perspective, and make sure they consider everything. So that is one thing people are doing, right? But then the tricky thing here is like implementing a single goal is already complicated, and then if you want to implement like a multi-viewpoint, multi-perspective, like even like human society is there's a conflict and contradictory viewpoints. So how do you balance those things? So that's what I think what Carla is pointing out, and actually that's out of scope for this particular project, because this project is trying to find out, okay, even if you have only a single-minded goal, how can you make the AI to follow that? And then the question Carla mentioned is if that goal itself is more complicated, how do you make judgment calls the AI at what point what it should be following? Right. Okay. And then the second one is curiosity is actually a dangerous thing to do. So why? Because AI is motivated to satisfy its own curiosity. It may do so at the expense of other things that we care about, like human flourishing or so on. For example, if the AGI is sufficiently curious about the pattern of digits of pi, it may feel motivated to wipe out humanity and then put supercomputers on Earth to like just calculate more digits. So for human, curiosity is the drive for being innovative and then learn more things. But so why that is not a problem for human, but it's a problem for AI? I have my personal perspective. I haven't seen it anywhere yet. It's because actually human by evolution is bounded. We have a fixed amount of lifespan, and then we have a limited amount of.
But also you have other instincts. You want to eat, you want to sleep, you want to have kids, you want to a bunch of things.
Right, and that's a balance of resources. It's actually a resources bound. So humans don't have unlimited resources to fulfill all my curiosity, even though that might be a good thing for people like Einstein. But evolution actually made that. So there's an unrelated study. Is there are people in biology trying to study why human has a limited amount of lifespan. Why don't we just live as long as we can? Because that seems to be better in terms of I don't know, developing civilization or technology or whatever you want. But what they found is actually that even though we may not like it, but that is a better way. Like there are several studies. One study recently published on Nature is every time when someone famous in academic die, actually that field make a lot of progress in the year after, because someone become like a very important person in the field, his idea will dominate and then suppress everything one else. So when that person disappear, a lot of new ideas can show up and then try new things. Yeah, so that's that. So for human, curiosity is something that got upper bound limit. So unless you become, I guess, head of a country, and then you want to implement your goals through the country's power. But that's where I guess democracy show up and to try to prevent that. That's what human society learned through the 1,000 years of history. Like it's not a good idea to give a lot of power to a single person. And then even in recent, what is that law? Like preventing company from being monopoly, right? That's the same idea. Is you just need to divide it up so that nothing is too powerful that can overcome everything else. And I think that might be even like if we cannot solve this problem, the solution might be just don't give unlimited power to AI. Then that will limit the harm it can make. Okay. So then there are several more challenges about achieving the inner alignment. So well, I guess Carla, you had, are you more clear to you now what's outer alignment and inner alignment?
Yep.
Okay. So inner alignment, first thing is there can be ambiguity in the reward signal. The reward signal means okay, let's look at the example. So for example, think about a BCI. Okay, so if you can put like a wire heading, literally means if you put a wire into your brain, like where it generates dopamine, for example, and then you can just press a button and generate dopamine. Then there's a famous experiment. They do that to a mice, and then the mice just keep pressing the button without eating and sleeping for 48 hours, and then it dies. So that's the problem here. So if an AI learns how to, its goal is to maximize its reward. So it becomes sophisticated enough, it may just hack into its own RAM and then override the reward registry to infinite, right? Because that would be a simple way to like just similar to what we said before about that Goodhart's principle. It's if there's a signal that you want to maximize, it may lead to unintended consequence. Negative reward and lying or negative reward for getting caught lying is close in semantic space, but can lead to very different in the goal. And how do you make sure your training process is making the AI learning the right thing? And then the second problem is called credit assignment failure. A nice example is a human superstitious. I guess.
Do you have the room until 4 only?
Actually, I think we booked the room next door. So maybe let's take a 5-minute break. We will resume in 5 minutes. We will just move to the next room.
Or we tell them.
Okay,
Oh,
sure.
yeah,
That
we
may be
can
a
tell
good
them.
idea as well. We organize. Thank you.
Sorry,
No,
do you mind going to that one?
If it's not taken. Yeah, we booked that room. We booked it.
Good idea.
Yes,
Yes,
good
good
idea.
idea.
So smart.
So how did you come up with that idea that aligns with our terminal goal?
Dopamine.
Right. Okay, so the second one is credit assignment failure. So human superstitious is an example is like you correctly made the observation and then you know what's going to come, but then you made a wrong reasoning. You assign what happened to an incorrect
To a
cause.
black cat.
Yes. Essentially that's the problem. And why that's that important to AI is credit can only go into the concept that's in its world model, right? So it can be the case that AI's world model simply does not have the concept that aligns well with the ground truth reward function. What that means is, remember we read a paper that Lambda 2 has the map of New York City, right? But if it doesn't have the concept of, say, like a little town in the middle of nowhere, and then you ask it to do something about that town, then that's where the problem can raise, right? Because it just doesn't know what you're talking about. And the same concept is, if you wanted to help us, I don't know, make paper clips without destroying human society. If it doesn't understand the concept of a human society, then if it on paper, just like it will say yes, but maybe what it think about human society is Minecraft. Then yeah, you don't know what is going to happen. And this is the same when we're dealing with kids, right? When we give instruction to the kids, they can say yes, but you don't really know whether they really understand what you are telling them to do until you see what the result comes out. So that's the scary part.
I think that
yeah,
that's true for me too. Like,
right, sorry, I should be more fair. Like, that's true for adults. And even, that can be true for anyone. It's just a human communication. It's just a communication problem. So the next thing is called ontological crisis. So what that means is when part of an agent's world model needs to be rebuilt on a new foundation. A human example is if a religious people has a crisis of faith, then finds their previous goal, like getting into heaven, are incoherent, but there's no heaven, right? So this is a problem with the AI model, right? It can have a set goal and learn a set of reward function and everything, but if its view of the world are changed, then a lot of those things needs to rebuild. And the problem is how to rebuild all of those things without creating problem. And the unfortunate aspect of this ontological crisis is that you don't know when they will strike. So maybe you have 7 years into the deployment and AGI has been very helpful the whole time, and you have been trusting the AGI with more and more autonomy, and then the AGI then happens to read some new philosophy book and it converts to how to say this? Panpsychism. Nobody is perfect. Okay. And then it maps its existing value onto its reconceptualized world. It finds itself no longer valuing the life of humans over the lives of rocks or whatsoever.
Somebody wants to enter.
Oh, Patrick is here. Hey, hello, Patrick. Okay, so that's a ontological crisis. It's like even if we build a good AI, because we're allowing the AI to learn on itself, to keep improving itself. So the problem is we don't know when the AI will change its view and no longer saying humans are their good friends.
I didn't know that word. Panpsychism.
Panpsychism? Yeah, I don't.
I don't know that either.
There's a lot of philosophical things.
You want me to put it on your chat and then you project?
Sure.
So put it on Webex, right?
Okay.
No, I'm not on Webex. I will put it on your Slack.
Wait, what do you want to? Oh, this work?
Yeah.
Okay, we can. I guess you got it on Wikipedia.
No, I put it on ChatGPT. But...
Okay, so panpsychism is a philosophical view that holds the consciousness or mental property are fundamental and ubiquitous feature of the universe. According to this, everything, including inanimate objects like rocks or electrons, have some form of. Oh, I see. Okay, so it just says.
Oh, so then AGI can conscious.
Conscious. So that's why. Okay.
Emergent properties.
I Google the Chinese now. I know it.
Okay. Okay. Oh, okay. That's why it says no longer valuing life of humans over life of rocks, because it believe rocks also have life now.
Yes.
Okay. Okay. Thank you. Okay. So that's a ontological crisis, and then the last one is manipulating itself and its learning process. So suppose we want our AGI to obey the law. We can ask two questions. So this one, bear with me. This is really difficult and philosophical. And Patrick, you can write on time. I might need your help on this one. There are two questions. One, the first question is, does AGI assign positive value to the concept of obeying law and plans that entailing obeying law? Means it believes obeying law, right? Oops, sorry. And then the question two is, does AGI assign positive value to self-reflection concept? I value obeying law and plans that entail continuing to value obeying law. First, try to give you 1 minute to understand what's the difference between these two questions. Okay,
so one I think is you can tell your kid you need to brush your teeth. Yeah. Because I will give you some stamps if you wash your teeth.
Right.
Or you need to brush your teeth. If not, you will have dental problems. So one is an inner reward if you want. It will do it because he knows it's good. And the other one will do it because it's getting something out. Yeah, external versus internal reward. I think that can go the difference. I don't know.
Not exactly.
In the self-reflective concept. Like, really, do you understand that it's good for you? Or you are told it's good for you?
That's okay.
But it would be like the same example, Kelly, like brushing your teeth is good for avoiding dental problems, but if the person experiences dental problems, it will self-realize that has to do it, right? It's kind of reinforced that actually that bad action happened.
Not exactly. And anyone else? Nick, Chen, Patrick, do you have some thoughts? Like, what's the difference between these two questions? It's important to understand the difference before we move on. No thoughts?
So, or maybe.
Oh, go ahead.
Go ahead. Go ahead.
I was just gonna say I think that it's a meta representation of itself. So is it, if you give it some goal that it is trying to optimize, but it doesn't understand kind of it doesn't have itself a representation of that optimization process or the values that undergird that goal, then it has lots of pernicious ways to optimize that thing. I think that I actually broadly agree with kind of toothbrushing example and things like that. That I think that's certainly related to this concept. But I think it's about whether it represents its own, whether it has some values framework that its own goal states are embedded in, or whether it's just like doing the optimization problem.
Right. Okay. I will share my perspective. It may not be. I think that the way I see this is remember there's a book called Fast and Slow Thinking, right? So we have to. So I think obeying the law is actually you don't need to think. You just do the action. Obeying the law is an action, right? So actually, that's something that if we go back to the first diagram, I think obeying the law is means the steering subsystem will just give you a good reward for obeying the law, and then I value obeying the law. Actually, it's like you say, it's a value proposition. So that happens in this thought assessor. It thinks, I think obeying the law is going to give me value and aligns with my alignment. So like the chocolate example, if like eating chocolate is something you do regardless, but then I value eating chocolate if I'm healthy or I like candies. That's something you choose to do. But you can also I eat chocolate, but I don't value eating chocolate because I have diabetes. I know that I shouldn't be eating chocolate, right? So that's and why is that important here? It leads to this concept of ego dystonic. So this is what it says here. So if the answers to question one,
put it, please, on.
Oh, sure. So if the answer to these two questions are yes and no respectively, or no and yes, like if the answer to these two questions are not the same, if they are both yes, then it's called ego syntonic. If they are not the same, it's called ego dystonic. So what is ego dystonic and ego syntonic? Okay, we can again go to Wikipedia. So ego syntonic reflects the behavior, value, feelings that are in harmony or acceptable to the needs of the ego or consistent with one's ideal self-image. And ego dystonic is the opposite, means your thoughts, behavior are conflicting or dissonant with the needs and goal of your ego, or further in conflict with your ideal self-image. So that's the that's the problem here. So it means if AI's action and its value are in conflict, then the AI may choose to change itself, and it's hard to predict like which way it will change. This is connecting back to Carla's earlier question, like if there are like, and obviously it shouldn't be just engineers designing AI. There need to be other people's perspective putting in here. But then if you have a higher order of preference that contradicts with the objective level preference all the time, it means you have multi-value system that you need to evaluate. How do you resolve those conflicts? Like this is even difficult for a human, right? Like I feel I always have something in my head that doesn't align with and a lot of people go depressed and they need to go meditation. It's all because we all have conflicting goals and value systems. So yeah, so same thing will happen to AI, and then it can lead to unpredictable results for us. And the thing is, the thing is, right now AI is like reprogrammed, but then for some reason that's what this sentence means. So there has been some context in which the pattern occurs naturally to human. So if you can do it for human, then it will also happen to AI eventually. So that's why this is labeled as dangerous. And then OpenAI's Superalignment project is actually they make a statement. How do we ensure AI system much smarter than human follows human intent? That's they call that Superalignment project. I don't know why they called it super, but I guess it sounds nicer. But the thing is, what they are saying is, it looks like eventually AI will become smarter than human in near future, and now we still don't have a tool to evaluate or control the future. So their Superalignment project is trying to come up with some ways to do it. And they dedicate 20% of their compute, and then they dedicate 4 years to have some reportable result. And their plan is to build, I forgot to put in here. So the reason they start this project is current way of making alignment is called human feedback reinforcement learning. So it relies on human to say, okay, is it good or is it bad, and then give a reward signal. So human is playing the steering system in that picture. But problem is, first, that's expensive. Second, eventually, there's a practical scenario they point out is it's likely we will more and more let AI write the computer program for us. Today, they are only writing a few lines of code, but eventually they will write like a super complicated computer software. And that's difficult for human to evaluate. So how do you make sure that the AI is not putting Troy backdoors or some other codes in there, try to get control of the nuclear warhead or things like that, right? So that's not for human reinforcement learning. That's why they say it's not scalable. So they are looking for a scalable oversight. So their plan is to make a AI system be an automatic alignment researcher. So they try to make AI to help human to align AI. That's a little bit, I don't know. That to me that feels like a little bit self.
They just make a
I don't
copy
find
of ourselves.
Right. But anyway, that's their plan. So they try to provide a training signal and task that's difficult for a human to evaluate. They try to leverage AI system to evaluate those things. So use AI to evaluate AI. That's they call scalable oversight. In addition, they want to understand and control how our model generalize our oversight to tasks we cannot supervise. Means generalization. But the problem here, I guess the point that these people are pointing out is like for AI to destroy the world, it doesn't need to pass Turing tests, because none of these problem, well, some of this problem here might be highly correlated with Turing test, but some of the things here, like for example, this one, it has nothing to do with the Turing test, right? It's just a training. So imagine if we are training a model, we don't want it to lie. well, don't want it to lie is like thinking about it as a human. But if you say we don't want it to write bugs in the code, like you can provide training signal. If 9 out of 10 times you give it a good training signal, like you call it lying and then you give it a negative feedback, but then there's a one time you accidentally say it's doing a good job, but it actually doesn't, then actually you are training the system to become a better liar. And this doesn't.
I think a lot of the point is, installing good habits before we reach that point, not necessarily waiting till we reach that point and then worrying about it.
Yeah,
that's what it sounds like.
Yes, exactly. That's what these people are arguing. Is you
you
cannot
may not be able to do beat the Turing test yet, but if you start building on a bad foundation, by the time we get to that point, you're in a lot bigger trouble than if you solve for or try to solve for at least those issues today when it's a lot more controllable. So just because it can't pass the Turing test right now isn't, super important to installing good habits.
Yes. And actually, that's what OpenAI is an excuse for itself to making a easier problem. So they try to solve an easier question. It's not trying to align the super intelligent or AGI, because right now nobody knows how to do that. But OpenAI is trying to say they want to learn how to align GPT-5 using GPT-4, and then iteratively, then you can always use the previous generation to help you build the next generation and make sure the next generation is still in line. And hopefully by the time you get to AGI, you have someone, I don't know, you have something a little bit less powerful than it, but still can compete with it. So that's their approach. And another thing they point out for the problem is evaluation is an easier problem than a generation problem. For example, it's easier for us to go on Amazon and then compare all the phones and then decide which phone is a better phone for us to buy. Then if we going to set out a manufacturer to build a good phone by ourselves. So evaluation is easier, and in many other cases. So what they say here is human may not be able to come up with a good solution to make alignment. But if we made the AI, what they call the automatic research alignment researcher AI, let it come up with solutions, and then our job will be just judging whether the proposal is good or bad. And that become an easier problem for human to evaluate. And essentially you let the AI do the hard work and then you be the manager.
Well, this is a very interesting talk, but I need to go.
Fascinating, Bo. You chose very well the topic of Friday and today. Keep it like that, and it's very, very, very interesting.
All right, thank you. Well, today is Halloween, so this is pretty spooky.
Yeah.
Right.
Okay.